this on?
No, because I'd be like,
Right.
no one likes
I
listening
shouldn't
to
have
their parents, but you don't have to like watch a video of it.
Okay, what we are going to do today, children. I want to go over how to do problems that our objects are in equilibrium. When they're in equilibrium, we know the sum of the forces equals what?
0.
0. In the x, in the y, or both?
Both.
Both. Okay? And those are called the conditions of equilibrium. Here's an example. You have a sign that weighs 800 newtons. A kid asked me this last period. They go, well, sir, shouldn't I multiply that by 10? By gravity. What do you say?
Slash.
Well, this is in newtons, right? That's force.
That's already.
When do you multiply this by gravity?
If it was kilograms.
If it's in kilograms. So if this said the sign weighed 800 kilograms, that wouldn't be the force, that would be the mass. So when you have a problem like this, if the sign is hanging there, and this again, this has shown up on several past AP tests, and I talked last time about the monkey example hanging from a vine, same kind of idea. First thing you have to do is you have to decide, okay, when I draw my free body diagram, note this is not a free body diagram. This is just a diagram of the situation.
Right.
But if I'm going to find the tension in the ropes and the knots and everything, probably the best thing you want to do is define what your system is. So I'm going to draw a dashed line, and that's going to show me what my free body diagram is centered on. So I draw a little dashed line, and now I'm going to draw my free body diagram separate from my picture. So, what things go on my free body diagram? Give me one, Paul.
Force of gravity.
Okay, which I already know is how much?
800 newtons.
800 newtons. So I've got that. I've got two other things that need to go on there. Give me one, Cody. Soldier. Okay, I've got two tensions, so I'm going to put one this way, and I'm going to put one this way. Now, y'all, I'm going to show you two methods to do this problem. I'm going to show you two methods, and the second method is actually easier than the first. But I want to show you the first method, and the reason why is because this method will always work. If you go into engineering, you're going to take a class called statics. And it's the weed out class for the engineers. And you have to know this stuff cold, and they'll have...
Not warm?
You know, but the method I'm teaching you will always work. The other method is nice, cheap little shortcuts you can use. Kind of like the velocity of the y divided by gravity. Remember that one?
It only
doesn't cost a lot.
Alright. Oh, funny. Alright. So first thing, once you've done that, if we're going to say it's an equilibrium and the sum of the forces in the x equals 0, I got to define what's my x direction.
Yeah.
So what I have to do is come up with a coordinate system. And I'm just going to use a traditional coordinate system in this case. This is x, and this is y. So you want to draw in your coordinate system.
When would you not do that?
Okay? If an object's on a ramp,
Okay.
there are times when you can take your coordinate system and actually tilt it.
Okay.
And we're going to get to that. Probably next week we'll get to that. Now the next thing is once I have these vectors, I have to do some geometry and figure out some angles. This angle right here is 35 degrees. Now how do I know that?
Because
Okay, how?
interior angles, alternate interior.
Didn't we already go over this?
Yeah, but
Well,
that's people weren't here.
Alright, yeah, a lot of you are
That's why
gone.
we're doing it again.
But, alright, if this is a flat surface here, a roof here, and if I look at this, this is the roof, this is the cable, it's 35 degrees. If this is the x-axis, these lines are parallel, aren't they? And so if I go this way, these angles are equal, alternate interior angles are congruent. That's a little geometry thing. When am I going to ever use this? Well, here's where you use it. This is 45 degrees, so by the same logic, this angle here is 45 degrees.
Right.
So the first step is break everything, is draw your free body, identify your system, draw your free body diagram, add your x and y axes. And these are all outlined on this paper here. Okay? Now once you've added your x and y axes, what's the next step? Who can remember who was here last time? Anyone? Keto, what's the next step? Cody pointed to you.
Find X and Y axis of them.
Well, you already have X and Y axis.
Keto, you played soccer?
Okay, the X and Y, what do we call those? Components.
Yeah.
So I'm going to draw those as sides of my triangle.
That's really good.
Okay, so I have my X and Y components, and now I have to find both sides of the triangle. They're right triangles, and all I'm doing is finding the sides of the triangle.
Yeah.
Now, just like we had a velocity vector when we knew this angle, the velocity in the X was v cosine of theta, the velocity in the Y is v sine of theta. Same thing here. If this is T1, this is T1 times the cosine of 45. This is T1 times the sine of 45. Over here, this is T2 times the cosine of 35. This is T2 times the sine of 35. Can you dig it?
Sure.
So those are our X and Y components. Okay. What's the next step? Who was here last time? What do I do next?
We have to solve.
Gennaro. You get to choose someone else.
Pick me.
Okay? Don't help him. I don't care if you pick him back. But you get to pick the next victim.
You start with the X component.
Okay, remember the equilibrium. What's the equation for equilibrium? I'll give you a hint.
Matthew.
Y'all remember what this stands for?
Sigma.
Sigma. It's a Greek letter sigma. And in math, it means the sum of. It means you're adding up. So all the forces in which direction, Gennaro? In the X. And what are they equal? 0. And I know they're equal 0 because if they didn't equal 0, it would be accelerating in the X, wouldn't it?
Right. That's not equal.
Okay? So this is one condition of equilibrium. The other one is the sum of the forces in the Y equal 0. Okay, please don't do that. So now, so what are the forces in the X?
Gross.
What are the forces? Let's start. We always start with our positive. It actually doesn't matter, but what's our first positive force in the X? Wait, Gennaro, pick on someone. Keto, what's your force in the X? Give me the positive one. What?
T2.
Okay, so
There you go.
T2 times the cosine of 35. And you know, basically what you're doing is on this side of the equation, you're saying, okay, what relationship makes these equal to 0?
Right.
T2 cosine of 35, that's our positive, minus what?
T1
T1 cosine of 45
It's really just square root 2.
equals 0.
Oh, look at you.
Okay.
Oh yeah.
Yes, he knows. Y'all, quit. At your age, not my shoe size. So what do we do next? Cody, what do we do next? I like this. What do we do next? Okay, well, I want to first get this T2 by itself. So Cody, solve that for me. T2, get it by itself. Tell me how to solve this algebraically for T2. In your head. How do I get rid of this negative? Okay, how do I get rid of the cosine? Divide.
Yeah.
So I'm going to end up with T1 cosine of 45 divided by what, Cody?
Divided by
Cosine of 35. So that's T2 in terms of T1. Notice I have one equation and
2 unknowns.
2 unknowns. You can't solve a problem if you have just one equation and 2 unknowns. So I have to write another equation. So who should I call in next to write the next equation, Cody? Keto.
What?
Hi. So what should I do next, Keto?
Find a Y component.
Alright, I need to... Alright, so tell me what to write here for my Y components. What? I can't hear you.
T1 sine of 45.
Okay, so I'm going to draw... You start with your positives.
Yeah.
T1 times the sine of 45
Plus
plus
sine of
T2 times the what?
sine of 35.
35 minus
800.
800, and all those equal
0.
0. Okay, I have one equation and two unknowns, but now I can solve by substitution, can't I?
Yeah.
If I can set up a matrix. But let's go ahead and solve by substitution. So let's take this value for T2 and plug it in over here. So, now, T1 times the sine of 45 plus T1 times the cosine of 45 over cosine of 35 times, that's T2, times the sine of 35. And I'm going to go ahead and bring the 800 over to the other side. Now, what we have here is a bunch of decimals. T1, if you plug sine of 45, you plug in your calculator, is 0.707. So 0.707 T1, or square root of 2 over 2, if you want to keep it in radical form. Sine over cosine is tangent. So cosine of 45 times the tangent of 35 should give you another. So anyone already give me the decimal? Or you can just do, if you don't remember that trig identity, you can just do cosine of 45 divided by cosine of 35 times the sine of 35. You get point something.
Square root of 3.
I want to know that. Just give me the decimal.
1.7, methinks.
Tangent of 35 times cosine of 45. And you get point, why did I put an equal sign there? Plus 0.495 T1 equals 800. Check my math, make sure I did that right. This is the best, easiest place where you make a mistake. And this, on the AP exam, these are a pain to grade. I hate giving these kind of problems on AP tests because they're a pain to grade. And most of your points actually come in setting it up. And one of the things they like to do in problems like this is not even make you plug everything and make you solve for things in terms of everything else. You'll see more of that later on. Yes, my
I
child?
didn't understand what you said on your shortcut for the cosine of 45.
Oh, sine over cosine is
Tangent.
tangent.
Okay.
So all he did is I said the cosine of 45 times the tangent of 35. That's a little shortcut. I mean, it saves you a few strokes on the keyboard. So now you add those two together, 0.495 plus 0.707, and you get 1.20 T1 equals 800, and now T1 equals what? Crickets.
Wait. It's gonna be. Oh, I got this. I got this, guys. I got this.
Here we go.
640.
Anyone else have it?
Wow, Cody, that's awful.
I got 665.
Dang it. That's close.
Anyone else
Yeah,
get it?
25 off.
I got 665.
No.
Yeah.
Close.
Alright, 665
Yeah,
newtons for T1.
The way I think it's not close.
But we're not done. What else do we have
Well,
to
if the
do?
answer is 0 and it's actually 25, that's too big.
Now, how do we find T2?
Oh, I mean,
I can
closest
plug this in
such a
up here
relative
now and
term.
solve for T2. T2 equals 665 times the cosine of 45 divided by the cosine of 35.
close for me is decimal places.
So times 45 cos.
Cos.
You have to go backwards on these ghetto calculators. Divided by 35 cos. And I get 574 newtons for T2.
So,
Yay.
Make sense?
Big bubbles.
So, step one, let's go through it again. Step one, identify your system.
Yeah.
Step two, draw your free body diagram. T1, T2, 800 going down. Step three, draw an XY coordinate system. Step four, find your components. This is all outlined on the handout I gave you.
Oh, it is?
Yes. On this little handout, I gave you how to do it step by step. There's an example problem, and it has one worked out. And I go through each of the steps on the example. Step three, write your equation for equilibrium. Start with your positive x's. Step, do the same thing with the forces in the y, and then the rest is algebra. Now that was the way you could do this. Let me show you an easier method to do these. And on the AP exam, they will accept either method. But the only reason I go through this way is because I want you to learn what you really need to know. I want to give you a tool that's going to help you. Even though Physics B is not the official engineering course, some of you are going to, the skills you're learning are going to help you in other engineering courses as well, in the other physics classes and so on in your life. All right. An easier way to do this problem is just draw a vector diagram. If I say this is T1, right? And this is T2, and I say this is 800. We know that. If I add these two vectors, tail and tip, what should I get?
0.
Well, if I take this one and add the tail of T1 to the tip of T2,
The result
Right.
set should equal 800.
and I know if I take this vector and add it to this, what's this side have to be equal to?
800.
800. And if I'm going to add them all tail to tip, I should get a resultant of 0. Because if I don't get a resultant of 0, it's not in equilibrium. So now I basically have a triangle, and the rest is kind of figuring out some geometry. I remember this angle here was what? 35. So this angle here is going to be, what, 55?
Yeah.
Nice addition.
Because it goes straight down. No. Yeah, yes. 55.
No,
Sorry. No. All right. So let's see. This angle here, let me get rid of that T2, move it over here is in the way. What's this angle right there?
It's 9. No, it's not.
Well, I knew this angle was what, 45?
Yeah.
So if this angle's 45, this angle is what, 45?
Yeah.
So 45 and 55 is what, 100?
Yeah.
So this angle is 80. Because this angle plus this angle have to add up to 180.
What?
Right?
Signal.
This is geometry.
Yeah, it's different.
So if this is 80 and that's 55, what's this angle here?
Oh, wait, I got this.
45. It's like the last one?
Yeah.
Yeah, 45. There you go, 45.
Because 80 plus 55 equals 135.
Thank
180
you.
minus 135 is 45.
Thank you, Cody. I wish I had a brass bozo button, but I don't. That was a prize I used to give away back in the 60s.
Dang.
I wasn't in the 60s, but that's what they used to call it. Alright, so I want you to look at this now. What we end up with is a triangle
Is that
where
the
I
second
have this
trimester
side
of
is
your life?
800, this is T1, this is T2, this is 45, 80, and 55.
Just use the law of science.
And to solve it, I can't use
There you
SOHCAHTOA.
go.
Why not?
And then degree angle.
Because it's not a right triangle. You can only use sine, cosine, and tangent if you have a right triangle.
You can.
So I have to go back and remember some of the other thing, and I don't think you learned this in algebra and geometry, but you learn it somewhere, the law of sines.
Yeah.
The law of sines says T1 over the sine of the angle opposite
Yep.
it
Or vice
is
versa.
equal to 800, that side, over the sine of its opposite angle, sine of 80. Now I can solve for T1. And if I do that, I get T1 equals 800 times the sine of 55 divided by the sine of 80. Now hopefully if you plug everything in, you should get the same answer we got earlier. Do we? Do you?
Anyone want to do it?
There's a seat right there. There's seats over there. Okay? So what do we get?
You get the same answer you got on the other one.
Did you try it? I didn't think so. Okay?
Do we have to try it?
Yes.
You have
Somebody
to try
get a
it and you have to
calculator.
just
What was
have
that,
someone
Mr.
know
Hurst?
Someone did it, and what if you get the same answer?
Harrison,
Okay, you get the
quickly.
same answer.
Do it.
Now, if I want to find the other side, let's use the law of sines. T2 times the sine of, over the sine of its angle equals 800 over the sine of its angle. We could solve for T2 that way. That's a little easier, don't you think? Do you like it?
Wait, on this get a calculator, do you have to go 55 sine or sine 55?
You have to go 55 and then hit sine.
Oh, wonderful.
On the ghetto calculators. On the TIs, you do sine and then you do the angle. Do y'all get what I just did?
Yeah.
And this is how I used to teach this to my regular physics kids and my pre-AP physics kids. We used to do vectors at the very beginning of the year. I didn't teach, but the component method where you break everything into components, that method is it's harder. But it works always, it always works. This method only works in certain situations. But on the AP exam, I've seen where they give different type of point values for it. All right, I want you to, let's look at this next problem, the last one on there, where you have the sign hanging from the side of a building.
Number
Like
one.
that one?
Number 3.
All right. Here we have the building, and this is supposed to be a chain. In my picture, it's a chain. And then you have the sign here. Bill's rule. I know you say they don't rule.
Are you gonna win your own man cave, Matt?
And it's 800 newtons.
I don't know.
Bill's rule.
0 and 5?
Is that like Latin or something? I can't read that. I don't know what that says.
And this is 40-degree angle. Right? And the question says, what's the tension in that chain? 600? Oh, you're back.
Yeah, it says 600, not 800.
Okay, 600 newtons.
600 newtons.
Now, so kind of, people are saying, well, I don't know what that looks like,
That is
sire.
0 newtons.
Well,
The mass
here,
of
if
the
I
Bills'
take this
victories.
thing right here, let's imagine this stopwatch is the sign, the Bill's rule. Okay? And this little lighter here, this lighter, something just happens when I see fire. But this little lighter is this little bracket here. So the way it would be set up is like this.
Careful.
Alright? And the angle that this makes with the horizontal is a 40-degree angle right there. And the question is, what's the tension in that chain? Right there.
I don't know,
Right?
feel it.
So that's the way it's supposed to be set up. Now people say, well, it's 600, that'll just be 600.
Not necessarily.
Who would say that?
Alright? Well, if we follow the method, first thing we do is identify our system, and it's going to be easiest, since all those forces kind of meet at that knot, draw your system around that knot. Yeah. And then I'm going to put a little dot here.
Is that the Bills' rule knot?
Oh, the Bills rule knot. I like it. Okay. The force down is 600 newtons. The tension is pretty easy to draw, is T. The question is, what do we do with this thing here? Well, it pushes outwards, right? But you don't draw the force going into the dot in a free body diagram. How do you draw it? You draw it as if it's pulling it, so you just draw it this way.
Oh, okay.
Okay, and I don't know what to call that. I'll call that the force of the pole, or whatever this is. It doesn't really say what it is. It's an outward force. Alright, now I'll show you this method, then I'll show you the shortcut. Now that's first step. Second step is set up your coordinate
Cartesian.
system. Positive x, positive y.
It's F pole.
Fill in your angles.
I don't get it.
That's
It's
40.
It's like a penis.
Now what's the next step, Paul Mata? Hello, Mata.
Good one, Matt.
Hello, Mata. Okay, so we got to break this into what? Right, the component. Thank you, Paul. Oh wait, that's not your name. I forgot we didn't have a name change today. It's the component, the x component, and the y component. So I break this into x and y components. So Paul, what is this side? Okay,
No.
times t.
Not you, Paul.
And this is the sine of 40 times t. All agree? Next step is I can write my conditions of equilibrium. Now you're going to find here, if I start with the x, tell me what to write. Miss Arteaga, what do I write? For the x, the sum of the forces. What are the forces in the x? Now start with your positive. What's our positive force? The force of the pole, right?
Yeah, full.
Yeah, it's kind of force of the pole minus
The
t cosine of 40 equals 0. So I know the force of the pole is equal to t times the cosine of 40. Well, that doesn't really help me, does it? So I'll go to the next step. Sum of the forces in the y. What are the forces in the y direction?
You got your t sine of
Start with the positive.
40,
T sine of 40 minus
600,
600 equals,
0.
so T sine of 40 equals
600.
600.
You can solve that.
T equals 600 over the... Now, this one I can solve.
Yeah.
And then you plug it in.
Okay, and if I had started with the forces in the y, I wouldn't even have to write this.
So,
See, the problem, all I ask for in the problem is what's t. Okay, because the way it's set up, I don't even have to, this is easier. I don't have to, like the first example we did, we had to do all that substitution and everything.
Yeah.
What do we have to do in this one?
it's
We ain't got to do squat, do we? And I can just plug it in. So what's 600 divided by the sine of 40?
Harrison, use your
I know what it is. 933 newtons. How do I know? Because I did this problem, I remember it was on the wall.
Is that right? Michael?
Now let's do the shortcut method. What's a shortcut if I wanted to draw a vector triangle? What are my vectors?
Yeah, your
The force of the pole,
pole.
the tension, and what's the force going down?
Your 600.
600. If it's in equilibrium, they should form a nice triangle, shouldn't it?
First tail to tip.
Yeah, I just added all three vectors tail to tip. And if I add all three, if you have something in equilibrium, then all the vectors added tail to tip should equal 0, shouldn't it?
No, it's tip to tip.
Make sense? The tail of T added to the tip of this, the tail of this added to the tip of that. So it's all tail to tip. So now I have a triangle. This is 40. This is 90 degrees. Find the hypotenuse.
Well, 600, wouldn't it?
Isn't that easy?
But it's not 33.
And so how do we find the hypotenuse? Opposite. You could say the sine of 40 is what? Opposite
600
over
over
hypotenuse. So T equals 600 over the
sine of
sine of 40.
40.
It's not as much work, is it?
No. Less.
All right, this is a lot easier. And you know, when you get to the AP test and you're getting a problem, this way always works. Shortcut. And a lot of the AP test is time. So any kind of shortcut you can take, go ahead and do it.
Makes us kind of wonder why you didn't make
shut
the
that
shortcut
down.
in the first place.
Can
You want
use the
me to
shortcut if it's
you want
not
me to
equal
turn it
to-
off?
What?
Can you use the shortcut if it's not